Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau, and with me is my co-host, Philip Wilson.
I'm excited!
And Justin is here, too. He's hanging out a little bit. Or
I'm somewhere here, yeah.
You're somewhere here. He's in the background. And anyway, so let's just get started on this. I'm just going to go ahead and get the screen going, because there's no sense in waiting. Oh, well... Okay, so opening the
there's
project.
a little bit of
There's
waiting.
a little bit of waiting. It has to import all of these assets. Why?
So many assets.
To fix this problem, donate a Mac Pro to Max Moreau.
Yeah, don't donate me a Mac Pro. I'm good. I really don't need one.
They can give me a Mac
how's
Pro.
your Mac Pro treating you?
Brilliant is a word.
Brilliant. Okay, cool.
Yeah.
That's awesome. I'm
All
gonna have
right.
to see that thing in action at some point.
I like your idea of making a Steam box out of my old computer.
You should do that. You really should. All right. So on our last episode, we had these little metallic spheres,
yeah,
and they
this
kind of
is
like
awesome.
orbit around things, and it just spawns them. And we did this because someone asked for crazy physics stuff, and we were able to deliver on crazy physics stuff at least. So this is a start for some things.
Oh yeah, that
And we've
that
got
cylinder
yeah,
capsule is just
capsules
getting,
are Mario type dude kind
It
of
is
thing.
just getting
but he
molested,
he's getting pushed around quite a bit. So let's get this started again. And this time I'm going to remove the crazy physics spawner, or at least disable it for right now.
I'm okay with that.
And I'm going to make this back into the default. Where is this material? No, wrong material.
What are we looking
This material.
for? Oh, the shiny.
Yeah, I'm just going to make it the default diffuse again.
Yeah, I think that's probably more appropriate.
It'll be easier to tell what we're doing if we
Yes,
actually
it
do
will.
get things working. So I hit play, and we have a player, and right now he drops down using gravity. And does he stick in the right place at least?
I have a person that says, wanted to thank you guys based on your advice on ways to get into the gaming industry.
Oh,
Well, you're welcome.
yeah.
Yeah, that's all I wanted to say.
Did you get in? Is that
Yeah,
is that
that's
what the
kinda
lead
what
up
I'm
here?
curious
Yeah,
about, like-
yeah. Let us know.
Yeah.
Let us know if you made it.
We are literally on the edges of our seats. Okay, maybe not exactly on the edges of the seats.
I'm just amazed here at what I'm seeing. This project looks awesome, but navigating in a 3D app without a mouse,
Oh.
your trackpad?
Yeah,
Dude,
I always do
I am a
trackpad.
lesser man than you.
Well, thank you. I've been using trackpads since before they were actually good. So I'm just like I was getting headshots on Unreal Tournament using a Micron trackpad.
The answer is, by the way, I've worked my way into a chance to work on a PC title being produced on Unreal.
Very
Engine 4.
cool.
Very
Well,
good.
congratulations. Seriously, that's awesome. I hope that works out well for you.
Yeah, Unreal 4 is pretty fun. I've got some experience with that, but
Awesome.
good luck.
Good luck. That sounded ominous.
Well, no, it's just Unreal 4 is it's very
This is its own thing.
Unreal?
The thing is, when I went to Unreal, there was a lot I had to unlearn from Unity because Unity makes it so easy and approachable, right? It's designed for people who want to make things.
That is true.
Unreal is more of it's designed for a team who wants to make things.
Yeah.
And so, I was pretty angry the first couple of weeks, but it's okay now. We're on speaking terms again.
You and Unreal,
Yeah.
you've made amends.
Yes, we have.
Good deal. All right, so let's see what we can do here. So the problem with the player right now is since he's physics based, he can kind of receive forces that may be forces we don't want him to actually get.
Unwanted forces?
Yeah, unwanted forces. And the problem with this is we can't just like zero out his. We could get away with certain things if we had certain assumptions like gravity's always down or things like that, and we could zero out like his X and Y or his X and Z and keep the Y and do some fancy stuff like that. But we can't really do it easily on an arbitrary angle on our sphere surface. And so I think For our first try today, I'm going to forego using the rigid body system and actually just manually move things around. So we're going to use is kinematic on our rigid body. And
There's a quick questions unrelated.
sure thing.
Can we get some advice for game jammers this week? This weekend is the Global Game Jam, and I'm
is
sure
it?
a lot of us will be participating because of you.
Yeah, I think I can make that happen. Let's focus. I'll see if I can get another day this week or something to do some game jam tips. I don't really want to blow episode time today on that, but we can. I'll certainly make a little primer type thing for it. I didn't actually know it was a global game jam, so that's
I had
cool.
no
I'll have to look
idea
into
either.
that.
Yeah.
How long a competition is that? Is that like a weekend thing, or is it?
I have
Yeah, I
no
guess
idea.
it's a weekend thing. That's what it says.
I can look
The
it
one
up.
quick
so-
bit of advice I had, and this is something that worked brilliant for us, is start at a restaurant. Spend your first hour with whoever you're working with, even if it's just yourself, figuring things out with food in front of you and not a computer. That worked out great. It saved us a lot of time.
It did actually. That actually worked out pretty well. This was for Get Your Pagoda.
Yeah. Up your
Up your pagoda. Yeah.
January 24th to 26th. Looks like.
Cool.
Neato.
All right.
Oh, middle of the week though, huh?
Is that the
Is that
middle of the week?
I don't think it's the middle of the week. Nope,
It's
that's
20,
the
no.
24th is
Yeah,
Friday.
24th
Oh, is it?
to 26th. Yeah.
All right. No, it's Tuesday, isn't it? For some reason I thought, or Monday. I thought it was Sunday.
All right, so
Yeah, you can find out more information if you want to know more about Global Game Jam at globalgamejam.org. That's all.
come on, player movement, open up. Come on, Mono Develop.
Oh, okay. I didn't interrupt in a bad time. Good.
No, you weren't interrupting anything. I'm just waiting for my computer to stop beach balling.
The
I feel
beach
bad it does
balls.
the same thing on a Mac Pro. It's Mountain Develop's fault.
Yeah, I know. I know that. Doesn't matter how fast your computer is, Mono Develop will cripple it.
Yes.
All right, so we're currently using AddForce. I'm going to switch this again to. We had this at one point as transform.position. So transform.position plus equals gravity vector. And times time dot delta time.
Gotta love time.delta time.
Yes, you do. Well, you don't have to, but
It
it helps. It helps to love
a
it.
lot.
All right, so now it should probably end up inside the sphere somewhere. Okay, cool. It did. That's awesome. That's because it no longer can collide appropriately with it because it's not getting collision messages due to the fact that we have a kinematic rigid body versus no rigid body at all. I'm pretty sure on the case of the sphere. Oh, it has a rigid body. Oh, interesting. Well, anyway, it's not working that way anyway. So what I'm going to try, though, is what we're going to do is instead of using this is going to sound strange, instead of using a regular collider, we actually just care if we want to be on top of this thing, and we're not getting collision things. So I'm going to actually set it up as a trigger, and then we're going to check in the player's trigger. If you get inside the planet, it actually pushes you to the outside of it. So let's see if this will actually work. We'll find out. So I'm going to make that a trigger, and we're going to go into I'm going to create a new one here. Void on trigger enter.
We have an interesting question. Is there any merit in keeping gravity normal and rotating the world instead of walking over it?
That's actually one that I was considering doing if all else fails, and it may actually not work very well even if we do it, but it would allow us to actually use a character controller. That's one advantage, is that we could use a character controller at least for the player. Because character controllers force a Y orientation on the capsule and assume that gravity's always down. But if we were moving the whole world around the character, it could potentially still work in that environment. And as I said, that's kind of my last-ditch, really strange effort to try and make this work. If
You are technically moving a lot more objects if you're moving the world.
well,
as
it's just one object. It would just be it would be one position. You would put everything in a hierarchy so that we
fair enough.
could get proper parent-child relationships between everything. So on trigger enter, I'm just going to make this so that
Not to be confused with improper parent-child relationships.
so we're going to assume that we're just working with spheres for right now. We're going to have to change this later, but it'll be a lot more complex. So I'm just going to get the basics in here first. So if we enter the trigger, I'm going to put in collider col. We're going to put ourselves on the outside of the collider.
Okay.
So what do I want to do? So transform dot position equals. So we have a gravity vector which points towards the center of the planet. So that's probably what we're going to want to use for part of this. So transform dot position equals negative gravity source, or gravity vector. So this is the vector pointing outward from the planet.
Mm-hmm.
We're going to multiply it by the collider's
Well, so many options.
okay. It's actually, because we're assuming sphere colliders on this, we're going to do sphere collider scol equals col, and we'll probably have to cast this to a sphere collider. That should work. This will allow us to get access to radius. So scol dot radius. So we multiply. Okay, and we also want gravity vector to be normalized. So dot normalized. So this will give us the point pointing away from the sphere, and then our actual position should be the sphere's position, the gravity source's position added to this. So it would be gravity source plus this whole thing. So negative gravity vector normalized. I guess I could just do minus.
Yes.
So theoretically, this should keep us on the outside of the sphere.
In theory.
I did something wrong. Transform position. Gravity source is a transform, so we need gravity source dot position. So we should see the player fall, and oh, he did something
Where is the player?
weird. Where did you end up? Oh, in the center.
He's very much in the center. Flipping around madly.
Alright, so the problem is we're still pulling him further in, and we're only doing this on collision, on trigger enter, instead of when he's staying as well, so we can't counteract his position stuff. So, just make it on trigger stay. See if that works any better or worse.
Yeah, it's worth a shot. About the same. If the player's still in the center, just freaking out.
Well, he's not freaking out as much.
Well, that's good.
Is it?
I don't know.
I don't either.
I mean, it seems like it would be good that it's not freaking out. Doesn't it?
Alright. So, what are we doing here? Let's do it in both.
See what happens. That's the fun part about this stuff. You can just do whatever you want to.
Let's give this another shot.
No, you still see that same thing.
Alright.
Yep. That's
Log
what I was hoping for.
checking.
make sure to get the spelling on that right.
Yeah,
Very
seriously,
important.
that's really important that is spelled exactly that way.
So it
So
is
I'm
getting
definitely
called.
getting in there.
The on-trigger enter is being called once, I'm assuming. I'd expect us to see it at the very beginning.
Let's see what happens if we change the equation just for fun.
For funsies. Oh, still the same thing.
Well, at least he's twitching out now.
We should see what kind of values we get when we
Yeah.
with those equations.
All right. Let's
Maybe we should print the gravity source position minus the gravity vector
let's
normalized.
do void on draw gizmos,
Oh, drawing gizmos.
and we're going to just gizmos dot draw. We'll draw a
And maybe try a negative gravity value is something that was
Sphere.
suggested.
actually let's draw a cube because we've got a bunch of spheres. Draw a cube, and we're gonna just give it this thing right here.
I do like gravity sources.
Gravity sources.
Mm-hmm.
And there was something else, size. We'll just do one vector 3.1. Save. Yep.
S-col down here
Yeah.
at the bottom doesn't
Yeah.
exist.
What is the current radius of the sphere? Oh, I know what we're doing wrong. Yep. Okay. Already figured out a big problem. This is probably going to fix it too. I'm going to leave this around just in case we do need it. So the problem is I'm using the collider size and not the object size. And the collider size is going to report 0.5 even though it's actually 0.5 times the scale.
Ha.
So let's just do col dot col dot transform dot size scale.
It is probably local scale.
Yeah, we'll do the we'll do local scale right now. So plus times the local scale, we'll just make it dot y. As I said, we're assuming spheres right now.
Yeah, I mean,
Everything assumes spheres for now.
3 exclamation points.
Yeah,
That's important.
it is. So now if we do this on this side, get rid of that double multiply, hit save, hit
Now let's see what
play.
happens.
Hopefully,
Well, it's bouncing.
bouncing, getting closer. Oh, it would be 1/2 that scale, wouldn't it?
Let's see.
Yeah, 1/2 that scale.
Oh, because it's a radius, because
Divided
this would be a
2.0
diameter.
F. Actually, let's do
Oh.
times 1.5. Yeah, because this would be a diameter, and we need a radius. Times 0.5 F. Now, it should actually operate the way that we wanted it to in the first place. Yay!
Oh, look at that.
It just sits there
Look at that.
like a king of the world.
It is the king of the world right now. That's interesting.
Uh-oh. What
It's
have I done?
simultaneously in 2 places at once.
Alright, so is there a reason why it's not facing the... Oh, goodness.
When that happens, why?
This thing doesn't have physics, right? Like, I'm not crazy. It's
It
kinematic.
should be
okay.
kinematic, yeah.
I'm not using just in case. That might be part of the problem, even though I don't think it is. There we go. Seems to be working a little bit better now. So right now, gravity's kind of working as a constant. We might change that in a bit here. What is that?
Why does it do that? Oh, you aren't moving the object without its parent, are you?
Thank you, Phil. Thank you very much.
Okay.
That will help.
Yes.
So that works fine. That works fine. Okay.
Yes, that would
So
explain
the problem
jumping.
was I clicked on it again, and now I'm moving the geometry, and
That makes much more sense.
it's still don't quite understand.
Well, where's the player
why.
located?
The
currently?
player is located here. Oh, it's in the center. It fell through. Okay.
Because
Yep.
the geometry
Because the
didn't-
collider's
yeah.
not. Yeah. All right. Got it. Thank you for solving that problem, Phil.
You're welcome.
Geometry needs an update.
Yes, it does.
Yeah, you can't let the geometry work on its own.
All right. So we have something that kind of sort of works. That's good. Let's go ahead and move this guy a little bit closer to the planet that he's going to start on. I'm going to reorient him so that he's facing upwards.
Okay.
I'm going to hit play. I just want to make sure that what his positioning is. So yeah. So we have it so that his facing is outward from planet. I can work with that. That's fine. So let's what are we going to do here? Let's put a camera on him. So we've got a main camera, currently views there. Let's pull it up here so we can see him. And maybe bring it in a little bit closer. -7 sounds good. 7.5. And 12. And then we're going to parent the main
to the
camera
player.
to the player.
Not the player geometry, but the player.
If we hit play now, we should see him fall onto the planet. Okay, cool.
Awesome. Now we need to get that sucker moving.
Yes. We're also going to have to change up some of this logic, but let's get
That's
him
fine,
moving first.
yeah.
So, we're going to make him move. So, what we're going to do is we're going to use the horizontal axis for rotating, and I'm going to use the vertical axis for movement. Honestly, it would be better to do something a little bit less stringent than that, but let's start with this and see where we get.
I think that's a good idea.
So, we don't actually need this in fixed update anymore. We can probably get away with that as update, but let me just make sure before I start changing other things and decide that we had broken it when we'd actually just broken it right here, and we already did. So, yeah, we'll do fixed update. If that fixes the problem of jittering, I'm going to go with it.
I'm pretty sure it will.
Yeah. All right, cool.
Yeah, it definitely fixes the problem of jittering.
Hence why it's called fixed update.
Mm-hmm. Because it fixes things.
It fixes things. All right.
That's not necessarily true, but...
Yeah, it can definitely break things
You
too
can,
sometimes.
yeah.
Yeah, lesson is when I'm here for these, don't listen to me. Seriously,
Whatever, you have as much experience with Unity as I do at this point.
just a different aspect.
Yeah.
A valuable and important aspect.
Alright, so let's move our players. So we're going to do this in fixed update. Let's just do this in update. We can move it in fixed update later if it fixes things. So we will do transform dot position plus equals. So since I'm using the z-axis to describe the normal against the planet, and the reason I did this is because it allowed us to use quaternion look at easily, quaternion look rotation. I'm going to use the y-axis for his actual facing. So let me actually rotate him so that he... Whoops.
Oh.
Yeah, that's fine. We'll do that.
Should we
180.
deparent the...
Yeah, that's
the camera
safer.
first?
Let's do that real quick. And then 180, and then parent the camera again.
Wow.
All right.
That was easy.
Yes, it was. So we're going to add the transform dot up, which represents his y-axis, times input dot get axis vertical times time dot delta time, and we want a time speed in there somewhere. Time speed, and we already have a speed variable. Excellent.
Oh, good deal. I don't remember what the speed did that we put in here.
All right,
Anything?
so it didn't do anything before. Now it will
Fantastic.
do something, theoretically. So I'm going to hit play, and I'm going to hit W, and
Whoa.
Huh.
How fast are we moving?
I don't know why it's doing that.
I think it's moving very fast.
Oh, maybe. Let's find out.
No, it's just flipping.
Oh.
That's
Okay, got it. It's because we are doing...
Pardon me.
So we're changing the rotation... Negative gravity vector,
Do
and
we
we need to
need-
give it an upward thing as well. So let's try to maintain its previous upward vector. So it'll be transform dot up here.
Do we need both the on trigger enter and stay?
We may not. Ooh, looking
There
better.
we go.
Moving back. All right, there we go. We
Look
have
at that.
movement over a three-dimensional surface.
That's pretty sweet.
Things are moving. That's good. That's better than what we had earlier.
We need to speed it up.
Okay. Well, we can do that easily. We just go to our speed here, and we just...
Yeah. Can we get him into orbit?
Well, we don't have the ability to jump just yet.
No, I mean, but like, if you speed him up enough, what's gonna happen?
This
We
reminds me of Goku.
speed him up enough. I don't
Yeah,
think
like
it's
put it at 50.
50?
Yeah.
Alright.
See what happens. That's kind of
really
hilarious. Yeah, we can't let him leave orbit yet.
Here, let's make it even higher.
Okay.
500. This might
Oh.
actually do it. Yeah! Woo!
Where's he going?
He can just fly. He doesn't care.
Is he
We
falling
didn't give
right
him.
now?
We didn't give him any rules about when he can apply this to himself.
Oh,
He can do it
here
right now.
comes-
Woo!
Here he comes. Look at him go. That's kind of awesome. Just one more time. Just let him. That's fantastic.
All right, let's go with 10.
Yeah, I think 10's good.
All right, so now let's see if we can get some rotating in. So what we're
You
gonna
gotta
do
have some fun
is,
sometimes, right?
Yeah, truly. Public, float, rotation speed equals. Let's go with
5?
20 to default.
20. Okay. Do we want to try removing one of the? I would say on trigger enter is probably less necessary than on trigger.
Probably.
Stay.
Let's go ahead and do it for fun. Save. I'm gonna hit play.
See what happens. Yeah.
It does mean that you saw that extra
There's a
frame where he
little-
does the little dip.
Yeah, we should just keep them both.
I'm gonna leave it on there because it almost adds an
You
element
like
of
the dip?
animation that it really shouldn't have, but it makes it feel like something happened when it
Pass.
landed. Pass.
Yeah.
I'm looking at you for answers, man.
No, I was just thinking of that dojo in the N64 version of Killer Instinct. You know, he was like pass.
Pass.
Like, I
Yeah.
accept that answer.
All right, so, oops, what did I do there?
For an animation, secondary
moving?
motion is bread and butter.
right, there we go.
Yeah, he bumps a lot more with that. I'm gonna put.
I think
the
we should
other
put
one
it back
in.
on. Yeah, I think it just helped a little bit.
I will make it so that we don't have to change code in 2 places, though. Let me
Make it
do that
so.
real quick. It still looks like it's a little bumpy even with that. All right, so what we can do is just make it void stay on sphere.
Does this mean he can't be launched off the sphere anymore?
And all we will do is do this stuff. And we will just do stay on sphere call.
And there we are.
So now if we make changes, we don't have to worry about it being in
Worried
the wrong
about
place until we're
duplicating the
testing it in the
changes.
wrong place, or which we've done on the show in the past, definitely.
Don't worry about that.
All right, so transform dot let's see, rotate.
Do we want rotate?
So,
Do we
yeah.
want Euler angles?
It'll be fine in this case. All right. Transform dot rotate. We're going to do
For many times, I would call it Euler angles.
new vector 3. I still want to.
I do too, but
Desperately.
I avoid it.
All right. So we're going to rotate him around our z-axis. So best way to do that. So we'll do transform.rotate, and we'll do 0.0f, 0.0f, and rotation speed. Then we'll multiply this whole thing by time.delta time. Save. Yeah, oh yeah, we need the rotation speed to actually be affected by our input.get axis.
This would be horizontal, I'm assuming.
Horizontal. Vertical and horizontal are already predefined in the input manager. So if you go to project settings input, you'll see that the default inputs have horizontal and vertical
Also
defined.
vertical.
And so they're usually keyed to your arrow keys, the WASD keys, and then additionally it's keyed to the left stick if you have a device hooked up. So let's see if this works now. So I'm going to go, and we're going to go forward. Sweet, going forward works. I'm going to try rotating. Going
We
forward
are
again.
rotating.
We're rotating.
Very slowly, but we're rotating.
Yeah, 20 degrees per second is evidently not fast enough for us.
It needs to be
Let's
more like
do
100.
60 degrees per second.
But 100 seems so fast.
All right, fine, 100.
Mm-hmm. That seems good.
All right.
Neato, we got the guy
So
moving.
we have a character. We can kind of cruise him around the planet. Let's make a texture for this real quick. I'm going to open up Neo
Yeah.
Texture Edit so that we can actually kind of see him on this object.
Sounds
And
like a
while
good plan.
that's loading, I'm going to hit Save Scene, Save Project.
Also a good plan.
Let's do this. This looks evil. Just going to use
We're
one of
going
the
for
built-in
evil?
ones. Yeah, it's all like lava'd out and stuff.
Okay.
I'm a fan of the Amiga text checker, you know, but
I could probably generate that.
texture coordinates on the sphere are kind of iffy on the poles.
Yeah, that's true. It's going to be iffy on the poles no matter what we use, though. So, text. All right, there's our texture, and we're going to throw this into Unity here.
So desperately want to say inappropriate things sometimes.
Don't say inappropriate things.
I won't. I'm well
As much as you
maintained.
want
I'm
to.
just going to point out that I want it.
Okay, and I'm just going to drag text onto our sphere. There we go.
Ooh, I like calling it text.
And we hit play, and now it should actually be a little bit more obvious what we're doing from our first-person
yes.
view. Yay.
Much more obvious.
Let's make this bigger. Let's make it like 20 by 20 by 20. Remember, we only support spheres so far.
Yeah, so if we were to change it, well, I mean, you could show what will happen if we change it. If you really want to.
All right. Well, I'm going to squish it out then.
Just one axis.
Yeah, we'll just squish out this axis and we'll hit play.
Roll is flat, you know. Wah.
So since we're assuming it's a sphere, we aren't going to get any of the...
So the reason that it happened to be very small this way is because we're assuming it's a sphere and we're actually getting just the y component. And in this case, the y component is smaller. We could also do it from one of the other axes.
No,
We'll get a slightly different effect. We'll get more of a floating around it effect.
Unless you were to go across the...
Yeah, it looks perfectly fine if you manage to stay on the edge exactly, which I'm failing at. There we go. Look, everything's normal. Everything's totally how you expect it to be.
Everything is normal. Pay no attention here.
All right.
That is pretty cool.
All right, so let's make it now so that we can jump, and let's make it so the gravity actually acts kind of more like gravity as opposed to like a
Magnet?
static. Well, no, magnets even have
That's true.
You're accelerating constantly, and in our case, we just kind of drop on at a constant rate. So, like if it takes 10 seconds to go, the first 10 units. Whoops.
It'll take 10 seconds to go the next 10 units as well.
Exactly.
It's a constant instead of an acceleration.
Yeah. All right, so
You're instantly at maximum velocity.
So let's create a. I'm forgoing using the rigid body physics stuff. We're kind of building our own physics system. That's the reason that we're using triggers in a place where it would traditionally be a collision. And since we're doing it that way, we have to actually keep track of things like velocity ourselves. And so what I'm going to keep track of is when the player's in the air, he'll be accumulating something to a gravity, and then a gravity velocity. I'm doing this not just as a vector 3 that represents the velocity because I want to keep it really simple, at least for right now. Mm-hmm. And this should make things similar enough to how you'd expect. So public float, and actually I'm going to call this private float. Private float.
Don't want anyone looking at it.
Well, we're going to be looking at it, but we don't want people changing it in the editor or anything because it doesn't make a whole lot of sense. We're going to call it gravity velocity.
Kind of rhymes.
Equals 0.0 f.
Could possibly be a song from a Disney musical.
All right.
Gravity velocity. It is so much fun to me.
All right. So right now, the reason the gravity seems to be working as well as it is because we're actually applying it. We're applying it in fixed update.
We're applying it every single frame.
But we're not using time.delta time in the calculation. Mm-hmm. So if I put time.delta time in here, it will look very slow. Which is fine, because it actually should be very slow at first, but then it should pretty rapidly accelerate. So we'll see this as incredibly lethargic drop here.
Actually, no, you can see it speeding up right now, like 18. It's at 17 now. Now it's at 16.
It's linear.
Oh.
Yeah, it's not speeding up. We thought it was, but it's not. So the way we're going to actually make it speed up is we're additionally going to take the... We're going to take gravity velocity.
Gravity velocity.
And we're going to add this in to our calculation. So gravity plus gravity velocity. And then gravity velocity will be set to the gravity vector dot magnitude plus equals. And actually, this is probably more than we need math-wise. We could probably actually just safely do gravity times... Actually, let's do that. So we'll do gravity times time dot delta time. It looks like the same amount of code, but it's actually a different amount of math.
Yes, it is.
So, vector 3 and float, what did I do?
Well,
Oh, gravity is a... No, gravity is a...
gravity's not a vector 3.
Oh. Let's try that.
Sneaky parens.
Did that. Did I save? I did.
Still angry.
Alright. It says plus cannot be applied to operands of type vector 3 and float. So vector 3 and float. So gravity vector equals, this is a vector. This is now,
Normalized.
so that's still a vector. Oh, again, order of operations getting me on this. As a matter of fact, that's all I needed to do. I don't
Yeah,
need
those
this
are
one.
superfluous now.
File save. Does that work? Thank you,
It
compiler.
does.
Thank you.
You compiled.
Alright, so
Still looks fairly constant.
it's just fairly slow. I don't think it's...
Well, we could do a print on the gravity. The gravity velocity. Just to make sure it's going up, because that should be.
Yeah, it should absolutely be.
But it would be interesting to see that it actually is going up.
It definitely is. You can
Yeah,
see
it's
the...
going
Oh
linear-
yeah, it's
you can see the
absolutely going up.
acceleration
I think if you
going.
were to put the pill higher up, the capsule,
Alright,
we'd probably notice it a lot more.
50.
Alright,
Play.
poor guy. Poor little fella. He's coming to terms with the fact that he's a capsule. Seeing what the world is. Falling swiftly towards a circle of something.
Circle of fire and ash.
Yeah. Just getting acquainted with himself and then, oh god.
It's so climactic.
Yeah. Just... Ting!
No, it was very anticlimactic in this case. He did not give, but we could make
Alright,
him give.
normalized times gravity plus
Saying.
gravity velocity times time dot delta
Particles.
time.
Can't go wrong with particles.
The particles can go wrong.
They can. Could go very wrong. So what are you trying to do?
I just am looking at this and trying to figure out what I'm doing wrong, because it does seem like this is falling incredibly slow still compared to what I would expect it to be doing.
Yeah, it does seem a little slow. Seems like it should be. Oh. That would probably make it move a lot faster.
It seems to be
Not a whole lot faster, actually.
set it to a factor of 10 to... Sorry, it's just...
Yeah.
Whoa.
So
That
the
is going to be
9,000.
incredibly fast.
There we go. Worked perfectly.
No, but
First try,
9.98
no
is
less.
the math
Yeah.
for
Yeah.
gravity, so...
Yeah, it is.
Should do a printf on that gravity vector. See what kind of numbers we're actually getting.
Alright, fine. You want the gravity vector printed out or the velocity printed out?
Gravity velocity.
Gravity velocity?
Yeah.
You want both?
No,
Oh,
the
okay.
actual
Oh,
gravity
velocity,
velocity. Right there.
Gravity velocity.
The one that kind of rhymes and is really fun to say. It's certainly going up. Look at that. have a comment that says gravity velocity plus equals gravity times time dot delta time. The delta time is necessary?
Well, yeah, because we need this based on time rather than based
we
on
want to speed
frames.
it up over time.
So our units are in per second, and so time
We
dot
are
delta time brings it
additionally
into per second.
Doing this in fixed update, is that something that we should consider?
Well, time dot delta time will still return an appropriate value in fixed update.
Oh, okay.
So,
Just throwing it out there.
yeah, I appreciate that. I know I'm doing something wrong here where I'm assuming acceleration is some sort of linear thing when it's not by the way I've set this up, I think.
It doesn't seem like it would be linear, though. I guess it would be linear considering how it's done. Yeah, because you're just adding... Or no, that's time dot delta time. No. You should...
Okay, regardless, let's get jumping in
know
there
what we
real
should
quick,
do?
and then
Real
what was
quick,
that?
just try gravity velocity times time dot delta time equals gravity velocity. So it's like a times equals itself.
You mean like this?
No. With the gravity velocity, though.
That is the gravity velocity. Oh,
So you're multiplying itself by time dot delta time. Try that.
that will just make it keep going smaller and smaller and smaller, but we can do that if you want.
Oh, it will, won't it? Maybe you should divide it by time dot delta time.
I don't think that's appropriate either, but
So what would that do, though?
all right, so gravity velocity times time dot delta
It would
time
just make it
means
smaller
it's just
and smaller and smaller.
Yeah, and it'll start at 0, so it'll be 0, 0, 0, 0 forever.
Never mind then.
And even if it started higher, it would just keep getting smaller and smaller until we got to 0. Divided by, it'll keep getting bigger and bigger, which is kind of what we want, but we don't actually want it for that reason or with those variables.
Maybe gravity velocity plus gravity times time dot delta time.
Probably this is what we need.
That seems a little better.
Let's see if this looks a little bit more like what we'd expect. Nope, still not great.
No, not great at all.
Somehow that seemed to have made things worse.
That's confusing to me. Why would that make things worse? Oh, because we're times equaling it right now. We should just
Thank you.
plus equals
That's
it.
the problem. Thank you.
That was my bad for suggesting a bad
that's fine.
suggestion.
Yeah,
There
that
we
feels a lot
go.
more
Okay,
appropriate
I like
at that point. It still seems, and actually, we don't reset it when you hit anything yet, so we need to probably fix that. Hold on.
Yeah.
So gravity velocity, if we'll just do that in here. Gravity velocity equals 0.0f.
Fantastic. I think that's more what we were shooting for, right?
Yeah. All right. Cool. And let's make a jump thing. So if
Do we want to? I guess we could
Do we wanna what?
we could turn off the gravity velocity with a bool basically as well if you wanted to. Just a suggestion in the fixed update. So like we can say as long as it's on collision stay, it's not actually applying any gravity velocity and setting it to 0. It's just a different way of doing the exact same thing that you're doing right now.
yeah. What we've got works right now, so. All right, update. If input.get button. Let's use jump. That's predefined.
That seems like a good call.
I like it.
If input.get button jump. We're gonna have to have some variables like private bool. Whoops, that was a lot of
Serialized
words.
private.
Private.
So,
bool grounded.
just out of curiosity, this is kind of a weird way of doing this probably, but couldn't you, after hitting jump, set the gravity velocity to a negative and have him essentially float into the air?
Yeah, we could kind of make him do that. It'll not feel like a jump. It'll feel more like a push off type thing, where he just starts accelerating
Could be
for
kinda
some reason.
cool. We should have
But,
that as a secondary.
All right. Well, we'll play around with making things strange at some point. We'll have plenty of opportunity for this on this. I'm gonna do a few episodes on this because
I mean, jumping physics.
we are
and
making
stuff,
some movement.
There are complete titles that ship things strange. You know, I mean, look at Sonic 4, and they
I don't
never
want to
got
think
the
about that. I'm
physics
sorry.
Jumping right on that.
I don't want to think about that one
To
anymore.
you, it's Sonic Team. Fix
So
it.
I'm just creating a variable called grounded that'll just be true if we're on the sphere thing, and we'll set it to false when we jump. So jump. What is it called? Sorry, grounded equals false, and then we need to actually jump. So, well, I guess we could. I guess we could always use the gravity velocity here, just like you said. Actually,
Let's try it.
all right.
What's the worst that's going to
So
happen?
let's set the gravity velocity.
Like -100. I don't know.
Let's do
I'm
public float jump value. I don't know what this. I was gonna say like acceleration or
No, it's not that,
it's
no.
like its own thing. So we'll just do
jump value seems good.
Let's default it to
100.
100.
Yeah.
F
1,000 dot.
velocity equals negative jump value.
Negative jump. Oh yes. Yes. Sorry. All right.
And save. We'll see what this actually does. So we get hit play.
Well, let's land first, I think.
Yeah, let's put him a little. Okay.
No, I like it. I like how quickly he falls.
Alright,
like
so
that.
he's down and hit jump.
That's
He's
interesting.
freaking out.
And white pill can't jump.
No, white pill can't jump.
Yeah, it's
Can
not
we
liking
make the
that.
capsule red or green?
Oh, you're-
Why is it freaking out like that? Hold on.
I don't know. It might be fighting with the fact that it's setting it to 0 instantly as well, since it could still be on collision stay. It could be fighting.
Oh yeah, we probably have to increase. We'll do transform dot position plus equals gravity vector or negative gravity vector times dot normalized times 0.1 f. Just
So we can just get them off.
move
of
them a
the-
little bit off of it.
Should we do that before flying the gravity vector, or does it matter?
It shouldn't matter in this case. Whee! I'm falling in a special way. All right.
It's
Yep.
still doing it.
Still not happy.
Interesting.
I find it very intriguing that it goes to the exact opposite pole of that sphere.
Yeah.
The radius is the same, but the...
Let's try just move them up a full unit.
I like that you can just move forward and it falls awesome.
All right.
Yeah, but still. Oh, that's interesting. Interesting. My harebrained idea didn't work quite right.
Let's make it 1,000. See what
Okay.
happens.
I'm terrified.
The planet just explodes at this point. Still doing the same thing.
Oh, I think I know the problem. I'm
Do you?
probably. Why am I getting to it? Because it was doing that even when we weren't changing the.
Yeah. The transformed up position.
Yeah.
Well, we should turn on the value of the gravity vector so we can at least see what it is.
Okay.
And the little debuggy thing. Because it should be equaling.
Oh, wait. Plus equals... So gravity velocity, let's say it's equal to negative 100. So we add... Let's not do this for right now.
Okay.
It's going to make it slow going again, but I'm curious if this will make it behave a little bit better.
Make it mind its business.
It's going to be a really slow jump.
Oh, man.
All right, so we're going to move it.
We have
and
touchdown.
Jump.
Houston.
Nope, still freaking out.
We do not have liftoff.
Let's try this trick again.
If you were to press it right now, what would happen?
Nothing, because it doesn't know that it's grounded yet.
That's very interesting. I wish I had that ability in real life. Just be instantly on the other side of the world?
But where would we end up? I
Oh, don't worry. In a mountain, obviously. That's usually what happens.
mean, or in the water.
Yeah. Water, at least you'd be okay for a moment.
Yeah. Aim for New Zealand, though, because Australia is designed to kill you.
That is true. You are right. It's so slow. There we go. That's better. What did you do differently? I wasn't listening.
I'm still flying away.
You
I may be
ventured
flying away forever.
So what was the issue?
I just really moved it far away from the planet.
And that worked.
Yeah, evidently.
Can we do the gravity velocity thing again with the gravity times the gravity velocity, or gravity plus gravity vector velocity? I don't know. There's so much gravity now. Let's see what happens now. Whoa. I think 100 might be too much.
I think it's set to 1,000 right now.
Oh, well, that would definitely be too much. It would come back eventually.
But we don't have enough time on this episode. Or not.
Yeah, I think that the way that we're doing the math assumes that this
Yes.
is not a negative, and it just...
Yeah, it's probably
Is
an
unhappy about it.
unfortunate way of doing it. We should maybe not do the negative jump value, though it's
Yeah.
kind of fun.
It is kind of fun. I'm just going to do these for right now. Alright. Jump logic goes here someday.
Someday we'll jump. Someday.
Failed experiments.
I'll
There
put
we
an
go.
unhappy face after it.
I still think that code, that exact quote is probably still in Psalm 4. You know, I can't.
Yeah.
Oh, I like that it has a happy face. An unhappy
An
face
unhappy
next to it.
face.
Yeah. Oh, I'm sad that this didn't work, kind of thing.
So you should see how I code at home. I have this dartboard. Where it's like, try this, try that.
You just
I have
throw
all these
darts.
holes in my wall, but hey.
You don't even hit the dartboard most of the time? Like, it has all these scenarios, but...
No, well, I mean, it kind of fits because it doesn't compile anyway, so what does it matter?
I like that we got the sphere moving around, or got this moving around on the
Yeah.
sphere.
Yeah.
I like
No
that.
gimbal lock.
Oh,
It's all quaternions and funness.
Oh, quaternions.
Well, you know, I'm actually happy with that.
Yeah, I think that's rather awesome.
Yeah, we at least got some basic movement over a sphere. The sphere cannot be arbitrarily sized. Those are two cool things.
Can we do something really fast to make it look a little
sure.
bit neater?
What do you want?
Just put a few more spheres in the environment,
You mean like this thing?
like planets.
Oh, I see what you're saying. Like,
background elements, huh?
Background
yeah,
elements.
yeah. We'll do that. We'll do that next episode because I want to actually do a transference from one to another at some point. So,
Okie dokie.
yeah.
One of these days we got to do a Cooking with Unity Particle Edition or something.
I agree.
That'd be awesome. You could totally help us out on that one. I'm assuming, because I don't know anything about the particle system.
You showed me Camera Stretch, so I tried it. Ouch.
Yeah, it's not so great, is it?
I wish I didn't know it was there.
I'm sorry.
It's all right.
All right. Well, anyway, thank you guys for joining us tonight. Had a good time. Hopefully you guys had a good time too. Hopefully we'll get more done on the next episode, but at least we got some basics in there. I reserve the right to change what we're doing at any time if we find a better way of doing it. Just like that. Yep.
Like that. That.
And so if you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire, DRAKFYRE. And you should buy Robot Alone, Phil's game, on iOS.
I always appreciate it if people buy my game. You can also email me if you want to. That's philip@protosoftworks.com. Or you can follow me on Twitter, which is much more likely for me to actually do something, which is at Magma Lemur. That's MAGMALEMUR at Magma Lemur. You should also donate to Cooking with Unity. It's a good idea. You just go to the Pushy Pixels homepage, and then it's up on the upper right hand corner.
Yeah, the Cooking with Unity.
YouTube.
Those tiles
The
are
YouTube
cool.
thingy.
Yeah.
Yeah.
They are cool.
Yeah, thank you, Justin, for helping us manufacture those.
I have no
And
idea
if
what
you
he's talking
if you have or have not received tiles or received the coasters, let me know. And if you have or have not received keychains, let me know. And we'll talk. I mean, either positively or negatively, depending on whether you've received it or not. But we'll get things figured out if there's a problem. So
Words will be exchanged.
yep. So thank you very much for joining us, and you guys have a great night.
Have a fantastical, magical evening.